And hello again, students. Here we are. This is a review for the final for BUS3010, and it has to do with the statistical process control and the capability ratio and index, CP and the CPK. Okay, so we're building on what we knew before, and what I've done is I've run some data, and what we're doing is we're producing some reads since it's the holiday season here. If you're watching this toward the end of December or the middle of December here. And what we're doing is buying. Let's put ourselves in the buyer position, and we have to check out and see what we're going to do with these randomly produced reeds. Are coming in from Canada, and they're the 8x8 by 40 foot containers that come in on trucks here. So we ordered a truckload of these, and we took some samples out. Okay, and we have 3 different stores, and we told that the producers, we said, if you give the reeds to us, and we told them shoot for 6 pounds average weight on these things. Okay, we're going to go by weight. That kind of means that you have enough bulk material in there, you have enough branches or bows or boughs or whatever goes into a wreath here. Okay, and we used a scrawled here 0.5 pound standard deviation. Okay, we're thinking that we actually gave them some specs on this, but what it turns out to be is they're going to probably be shooting for like a half pound for their standard deviation. What does that mean? On average, the reeds that they produce differ from the mean by a half a pound, right? The average distance to the mean of all the points. So the weights are the points here. So the average distance to the mean, it's like the average distance to the mean, and we come up with 0.5. So the average distance to the mean is 0.5 pounds, varies about 0.5 pounds. Always think about this in application. What are we talking about here? All right. So most of our things, how much? 68% fall between -1 and +1 standard deviations. Okay. So we get our reads in here, and we take 30 samples of these, a couple thousand sitting in this trailer that we bought, a container load full of them come down from Canada. So the data that we have for these are the weights that we have here. Okay. And so what I'm going to do is I decided to start out as a much longer video, so I slowed it or sped it up a bit by just showing results. Okay, so I've run the average on this, and actually they held to the average. They're pretty good with that. Okay, so they came in with an average of six pounds. All right, and so what I did is what we normally do. Let's run this thing by hand. We'd be able to run these things by hand, even though we do have the standard deviation function from Excel. So what is the first thing we do? I'm going to show you along the way here, I'm going to reveal these equations, right? So we're going to take our data point, which is E4, and we're going to subtract F4, which is the average, and we're going to square it. Notice the square at the end. Okay, so for every one of these weights, we see how far away it is from 6 pounds, and then we square it. So they actually come out as little squares, all right? That's an area. That's the area of a square, okay? And what we're going to do is add those all up, and they all add up to 4 pounds squared. Makes no sense whatsoever, because when we square a pound, what's a pound squared? Okay, so what we did is we divided by n. Okay, so we're just using the simple formula for standard deviation. I'm going to write it in here really fast because it was in here in my earlier video, but it came out again. Okay, so what do we have here? I don't know if I can write on here. Oh, great, we can. All right, so our standard deviation, we talk about it as being sigma, is equal to what? Just remember that it's the square root, okay? Highly focused on the fact that it's the average distance, so that's a distance from every point. There's the point, there's the mean, okay? Average distance to the mean. Get some of our pieces in here, okay? All right, so we're going to sum all of our points up from I is equal to 1 to n. Okay, we're going to add all them up, but we have to take the square of that. And then that's what we're just going through right now. And so then we end up taking the square root of all that. I just wanted to throw that in there for a reminder. I'm going to take it out now. So otherwise it's going to be in the way later on when I start moving things around. All right, here we go. So we got as far as the average of all those squares. And then we have to take the square root. When we take the square root of that, we end up with the standard deviation, and that's the calculated. Here's the long form. Okay, so we did this all by hand, all right, and we came out with this number. There's the standard deviation, and just for sureness, I used the standard deviation using the population to make sure that our longhand calculation we should always be able to do. All right, okay, so what I did is we ended up with a standard deviation of 0.37. That's somewhat lower. Actually, they held their standard deviation. They were dead on for the weight. The average weight was 6.0, just like we'd like to have them. And they actually came in better than we normally ask for. We say about half a pound, and they came in at 0.37 pounds, average distance to the mean. Okay? So what I did, and you'll be seeing some things revealed here, is I said I took my 6 pounds, and for multiples of standard deviation, because in these types of problems we use that symmetry type properties of normal distribution. These numbers up here, okay, what these numbers represent, I'm going to fix them really quick here. Control X, I'm going to move that over to Control V, put that in there, okay. And in here we're going to put in nominal. And what that means is, here's our center point, okay. So I created a little chart here. I'll center those up. Okay, center them up. All right, and all this chart is saying now is it's 6 minus 1 standard deviation gives us 5.63, and 6 plus 1 standard deviation gives us 6.37. There's that 0.37 added to 6, just to give a little bit of a visual check, make sure we're on target with that. So we normally use a 3 sigma system. So what I did is I pre-calculated these numbers so it works out better later on. So what all I'm saying is here's 6. Okay, and plus and minus 1 standard deviations out puts us at 5.63 and at 6.37. Okay, and then if we go out 2 standard deviations, that puts us at 5.26, and up here it puts us at 6.74. And then at plus and minus 3 standard deviations, see these are equal distances. I'm just marking it up a little bit here. So it's 4.89, okay, and it goes up to 7.11, okay. So now we can draw our curve. How do we know? Because we know that we'll even draw the middle part of it. There's the middle part, right? 2 standard deviations out is right in the steep part, and 3 is at the tail, so we'll connect them up like this. All right, I'll try to connect them up. All right, and where does the minus 1 and 1 standard deviations occur? Out on the shoulder somewhere like this. All right, so this gives me somewhat of a target. So the 2 standard deviation falls right in the main part of the curve here, and on the shoulders we should have our plus and minus 1 like that. Okay, so I'm lining these up so we can see them. All right. That's all I'm showing in that little table. All right, so keep that in mind. That's our actual operation. Okay, so our supplier in the supply chain, this is what they held to this time by us sampling these things. All right. Now, if you remember, what do we say? Give us, plus and minus, suppose 5. Let's go half a pound, 6 plus or minus a half a pound. All right, just to compare markings on here, we would be down at 5.5. and we would be at 6.5. Okay, where do those points end up? Okay, all right. So if you look at it, suppose one of our stores, that was their spec. We need to have our wreaths between this because our choppers are picky and they're discriminating, and they can tell that if there's a big range in the weights, there should also be a range in the price, but we're charging one price for all of this. So we're going to have to send, if we got some really good container full of these things, we'd send them to our very picky customers, and if they're really spread out. So we're already beginning to see that we're just about, for the really picky customers, our 1 standard deviation is just about, it's just inside what the customer requested. What does that say? For picky customers, right, we're running about a 1 sig system. We have a lot of waste, all right? They would take, now normally it'd be 68, but we're a little bit outside of their 5.63. So I'm just going to take a guess. We can go to the tables. We can go to the tables and we can figure this out. But I'm going to take a guess. I'm going to say that our yield for them is going to be about 71 or 2%. Okay, because we have a little bit of area. See, our 5.5 is outside the 5.63. It's to the left of that. So we're picking up a little bit of area. So we would have to end up pitching, what is that, 32 to 29%. So 29 to 32% of these would not be bought at the picky store. Got it? That's what this is all about. Okay, throw a little math at this and common day problems go away. All right. 6 plus and minus 1, so that's minus, that's plus. 6 plus and minus 2, that's minus 2 sigma, that's plus 2 sigma. 6 minus sigma, 3 sigma, 6 plus 3 sigma. Okay, so let's take a look at this. Let's see what's going on. All right, so for store 1, let's start taking a look at a little bit of a different perspective here. Okay, so here we said, okay, the store will take from 5.25, the number's a little bit different here, 5.25 to 6.75. Where do our numbers overlap? You can see that here, if this is our first store, okay, our numbers would be just inside here, right? Because here we have 5.63 for the one standard deviation. It's just inside the 5.25. This is the spec, okay? So we're going to throw out everything to the outside of this, right? So it's 6 plus or minus 0.75 pounds, okay? So for the more accepting store, we went and made it twice that, 6 plus or minus 1.5 pounds. So we'll take anything from 4.5 to 7.5. Let's do a quick look at our chart up there, and you can see that we're getting into the 2 sigma area. Notice the numbers here. What we need to get at is 4.5 and 7.5, okay? All right, and then finally, we have our third store. Okay, our third store, very accepting customers. They otherwise probably shop at Walmart all day long. All right, and they're picky. They'll go through these things, but they'll buy the last ones that are left over. You see, okay, so people will probably buy the heavier ones that are thicker at first, and then they're less discriminating. They might go first, but all of them will go. Okay, whereas all the ones that we produce. Let's take a look. Let's try to mark this down on our scale here. Let's see what's going on here. Okay. So 3.75 and 8.25, if we can start looking at the CPs on this, right? So what's the range there, okay? So the range there, if we do a CP on this, let's do the CP on this. That's going to be upper spec limit is 8.25 minus the lower spec limit is 3.375. And now what? We're going to divide by what? We're going to look at, I believe our 3 sig are inside these marks. I think our 3 sig are like this, right? Okay. So what we need to do is we're comparing this distance, the upper and lower spec distance, that's this up here, right? What's that going to be? That's going to be 4.5. We can already see what's coming up here. It's 4.5. I'm going to mark it down here, 4.5. Okay. And we're going to compare it to how wide our operation or our process is, 3 sigma, right? We're going to look at the distance from way up here. What's the highest point of plus 3 sigma down to the lowest is 3 sigma. So we're just looking at 6 sigma. We're going to compare that. And what was sigma? Like it was 0.37 something, okay? So let's do a little math there. We know it's 4.5. I'm going to type it in here. 4.5 is going to be divided by, and we need equal to 6 times. And so we're going to use the actual number so we don't have rounding errors. So I'm going to come back up here. I'm going to grab our well-earned okay, so it's going to be 4.5 over 2.2. 4.5 is obviously larger, all right? In fact, when we do the math, okay, let's do the math over here. It's going to be equal to 4.5 divided by that number. It's almost twice as big, okay? So in reality, if we really did this accurately, our spec limits, see if I can grab a hold of these. This is going to be a little bit tricky. Good, they're coming out all at once. Okay, I'm going to draw them more to scale here. Delete, at least for this image, all right? Okay, and it says our distance, so we're going to be something like this. 1, 2, 3, 1, 2, 3. So you see how this distance is about half, or let's put it the other way. Let's put their upper spec limit minus their lower spec limit is 4.5. Okay, it looks like it's almost twice as large. Otherwise, what we're saying is we have nice edges to what we're doing here. What are we saying? We're saying 99.7% of our production occurs between -3 and +3. This customer is so accepting, they're taking everything. We probably are out, if we really measure it out, we're probably 5. Okay, so we're probably at plus or minus 5 sigma for this. So this is like a 5 sigma system that we don't need. Okay, so all we were shooting for was 3 sigma, and we overshot, and it ended up being that the customers are actually buying off the tails that we would have normally scrapped. Okay, so then if we come up here and we do the similar thing, okay, what's CP? CP here is going to be equal to 7.5 minus 4.5. Okay, so it's a little tighter, right? So now it's going to be 3. Okay, and still, now we didn't, in this case, we didn't change sigma. Here we're looking at customers changing the goalposts, where normally, or otherwise, it's not normally, there's no normal, but otherwise we're looking at moving or improving or changing the curve of production. Here we're accepting one level of production that the Canadian company gave us, Christmas Tree Wreath Company gave us, right? And we're trying to find the store that we can sell them in. Can we sell them in here? Yeah, pretty good. Okay. Can we sell them here? We can, if you're already working ahead, it's going to be 3 over 2.2 something, right? So I'll do the math real quick. Equals 3 over, we have this number down here, 6 times sigma is 2.2. We're just going to reuse that. Okay, so it's still greater than 1. In other words, where are we? Let's see. Where's our limit? It was 0.37, so it was about 1.2 or 1.1. Okay. So we're still falling within a tighter band. Store 2 will still take it. Let's just do the math on that one. Just to figure it out, it was 4.89 to 7.11. Okay, so that's our actuals. That's the actual production number. It says it's 6 plus or minus 3 sig. Minus 3 sig is 4.89. Okay, you understand? So I can draw them in here. Where's 4.89? 4.89. This would be like 5 here, and this would be about 7 here. Okay. And I already forgot the numbers. Let's go back again. 489, 711. Should be able to remember 711, right? 489, right? So 489 would be somewhere in here. Yeah, this is the lower end of our 3 sigma system where it's producing right there. So we look like this, something like this. And 711 was up here. It's like this. I have a different setup for my pad, so it's a little bit shakier today. All right, there you go. All right, so you see, this is our 6 sigma. This is how big our 6 sigma is, and it's less than. Sorry. The distance between what the customers will buy. We still have room there. All right. Now keep in mind here, if we get another shipment and let's suppose that the standard deviation doesn't change, but the entire weight shifts, everything in there, the mean shifts, the entire process, they came out a pound lighter or something, and that would end up shifting all of our points over to the left, and if they came in heavy, it would shift them over to the right. So you see, because we have some elbow room or wing room or tail room, call it, so we have some tail room to play with. If this curve shifts around like this, then that's what gets us into the CPK. If it shifts to the left, and that's an example of it shifting to the left, right? If that shifts to the left, we have some shoulder or what did I call it? Tail room. We have some tail room here in the tail that we could shift by. We could shift, and we could still hold 3 sigma system, which is actually plus and minus 3 sigma. What we call plus and minus 3 is what we call 3 sigma, right? And that's the point of what CPK is, all right? And then finally, let's take a look up here, and guess what? When we take a look at the best store here, right, we're going to come in at 4.89 is going to be lower than that. 4.89, okay? And then our upper, on the upper end of things, we have a 711 up here, right? 711. Okay, so if we just do a simple CP on this, CP is going to be equal to 675 minus 5.25. It's going to be 1.5, okay? So we have to fit 3 sig between 1.5 pounds, okay? That's the range that they're giving us. And we already know that it's 2.2, right? So let's do the math. So it's going to be equal, the actual CP is going to be equal to 1.5 divided by, how long was our 6 sigma? It was 2.222, right? Hit that. I think something went wrong, and this happens when you don't put in your equal sign. Now we'll do that one more time. Okay. So as you can see, our process capability is less than 1. Uh-oh, that's bad. Okay. So we start out bad, and what would our actual reject rate be, or acceptance rate, right? So what ends up happening is, here's 3 sigma. See, we start outside there, or they start outside our spec limit. I keep going the other way, but they actually are coming in not too great. Okay, so what ended up happening is, if we short shipped this, and we bought these wholesale, and we move these to the goods store, then we would lose. There would be customers that would not buy outside here. They wouldn't buy outside their specs, which are these dark blue lines that I kind of overwrote there. All right. Okay. So that's that. All right. So what is the actual reject rate here? Okay. So normally we're willing to eat like a 1/4%. All right. Let's figure out what we're going to eat here. So what we're going to do is we're going to say, we'll take our point. We're going to use the table now. Notice that I have the table in here. You'll have a table for the final. Okay, a Z table that is, right? Okay, so we'll take our point, which is 5.25, and we're going to go subtract the mean. Notice that's going to be a negative number. Okay. All right. And then we're going to divide by what? See, we're going to compare that to how big our sigma is, okay, which was 0.337. Okay. I'm just going to type the numbers in here. 5.25 minus 6, that much, over, come back over, get my 0.37. And I just have to give it another paren at the beginning. Boom. Okay. Okay. What did that tell us? It says that this reject rate is right here at 5.25, and that occurs at minus 2.02555 standard deviations. Okay, if we turn this distance into standard deviations, it comes out as minus 2.0225. Then we run to our table, and we look up 2.03. Okay, we're going to do around here. So we've taken a look at the CP. We got a sense for what happens here. We used a different example than we used in the classroom, where we held the goalpost steady and our process changed. Here we have one process. Our process doesn't change. Okay, so we're looking at the loss to the left, what I just highlighted there in the yellow. Okay, so this is the example of the prime customer there. Okay, so we are operating, our 3 sigma is out beyond, lower than the lower spec limit on that. So we are going to lose something. We have to figure out now what is actually the problem. How much are we actually losing from this? Okay, so we had calculated a Z of minus 2.02 approximately up there. We multiply by 2 because you have to get the right-hand side. There was a little error in my Z table I had to go off and fix, so we're back and we have it working again. You can see where I have it highlighted there at minus 2.03. Okay, that's what we're after. If you look at the rounding, it was 2.03. So take a look. I think it was approximately 2.21% that we have there. 2.21% would be 1 tail. We have to accommodate 2 tails. .12 times 2. We end up with about 99 point what? It should be 95.74. 95.74. Okay, although I had written 99.74, it's 95.74. Okay, that's close to what, if you look at the numbers, it was close to the 2 sigma level of rejection or acceptance, rejection acceptance there, right? We're normally about 95.7. We had been 99.74. That's the point there, and now we're down to about 95.25. So the CPK are going to be the same, okay, until you start getting a shift. So let's talk about the shift for that middle customer of ours, all right? And what we're going to take a look at is what happens if we shift down so that our left tail at the 3 sigma point, so at minus 3 sigma down from the mean, okay? What if we start shifting? You'd have a situation here where the reeds might be drying out, okay? So when they put them into the truck, they were all at the right weights. Everything was matched to what we were looking for. But by the time they get to us and they get to the customer, they've been dried out. That's what's going to give you an entire shift here, okay? And in industry, what they'll do is they'll accommodate that, soak them, or they'll understand what the shrinkage rate is of these things by the time they get to somebody like us, and they would actually be careful about speccing it. And certainly while they're sitting around outside in the sun, they're drying out also, so the needles are falling off by the time anybody's going to use them. All right, so that's everybody's interest here. The middle customer here took 6 plus or minus a pound and a half. They're willing to sort through these things, but if they're too light or they're way too heavy, I don't know, they'll be tearing off the door if they're too heavy. If they're too light, then that means a lot of needles fell off and they're too dry, or they just get the sense that they're on the light side. They're not getting the quality for the same price that they should be getting there. Okay, so what we're going to do is mark down the minus 3 sigma point is 4.89, which is 0.39 above the spec limit, right? Lower spec limit is 4.5, and we have a minus 4.89 is our minus 3 sigma level. Okay, so we have some room here to move. This is the point, is that these things can dry out, and yet the customer will still accept them. What do we have? We have 0.39 pounds to play with. Okay, this is where CPK comes in. Okay, CPK, CP are going to be the same if there's no shift. Okay, and there's a very distracting formula for CPK. We're going to go over that and we'll show what that means. So if you notice, there's a 0.39 difference between the location of our minus 3 sigma mark, right? And so our entire process can shift down to the left like the wreaths are drying out on the way in. All right, so we have 0.39 pounds to actually play with and maintain our 3 sigma for the satisfaction of acceptance rate, yield, that is, and rejection rate. Okay, so we're trying to protect the fact we're selling more now, you see, because our minus 3 and plus 3 fit within the spec of of our customers, our upper and lower spec here, right? So we can move this whole entire curve down. Okay, so these things can dry out by 0.39, and we shouldn't really see any difference in these customers that we've really studied, and we know that this is their spec limit. This is what they buy between. They fail to continue buying once they get too light. Okay, they're all dried out. All right. So we use CPK to do that, and it can be a little bit distracting, but it's actually quite simple. All right. Within this, we're going to look for 2 distances. You notice that the entire shape moved, which means the mean moved down. Everything moves together by the same amount. And so what we're going to do is compare the mean to the lower spec limit. Okay. If our product is shifted to the left of what we can accept, okay, the distance from the mean to the lower spec limit will have changed. It will have gotten smaller, as a matter of fact. Okay. Now, all we're going to do is compare the mean to the lower spec limit And we're going to compare that distance. If we subtract the lower spec limit, which is a smaller number, from the mean, right? We get a distance there. And all we're going to do is compare that to the difference of the mean and the upper spec limit. And that's what that min, that little fancy formula part in here that calls it min. We're looking for the smaller number because that's the danger area. We're crashing. We're moving toward the where we once had some leeway on either tail. Now we're eating up that extra tail, and we're actually going to at one point crash into the lower spec limit. Okay, so that's what this is all about. We look at how close it got to the lower spec limit to how close it got to the upper spec limit. One of those distances will decrease, one of them will increase if there's any shift at all. I'm just assuming there's a shift. Otherwise, CP and CPK are the same. All right. So you have the shorter distance. We know we're headed toward this lower spec limit in this case. All right. And what we do is we take that distance to the lower spec limit and we compare it to our very protected 3 sigma. How long is the 3 sigma? Well, if we're still further away than that 3 sigma, then we're safe, right? Well, we take the mean and we subtract the lower spec limit and we divide by or compare it to 3 sigma. Okay. You can look at this problem and you can ignore the upper spec limit part of this, the right side, because you can already see if you do all the work and you map this thing out and you draw the pictures, you can see we're look at the data and plot it like we did. We're crashing into the lower spec limit. All right. So now we can actually calculate our CPK. Okay, so we subtracted 0.39 from our 6. We got 5.61 is the new location of our mean, right? So we take our mean and we subtract the lower spec limit, which is 4.5. Then we divide by 3 of our standard deviations. Let's go use the full value of it. Okay, so when I go and grab this, that means I'm using all that precision. We don't get some rounding errors and going on in here. Good practice. Okay, got to come all the way back over here, finish off the formula. Okay, and so what do we end up with? For all intents and purposes, there was one spot in here where we did use a rounding number of 0.39 is actually a rounded number if you look at what we did here. So we came out to 1. Okay, so let's just show what happens. Our CPK will show that we have a capability of exactly 1. 1 is the number. Okay. So CPK would be greater than when at the center point it's going to be 1.3 or whatever we calculated before. And now it's going to be 1 because we shifted it down. I picked a very arbitrary number to show what happens when the actual -3 standard deviation starts hitting the lower spec limit. And basically, that is what CPK is about. And you could run, I'm going to try to keep this a little bit short for this video, but you could run through the problem with the more discriminating customers at our Whole Foods versus our Walmart customers. You could run the numbers on there, but I think this demonstrates what we really need to show about CPK, how it changes. Starts out, you can prove it to yourself, it starts out as CP if it is centered. So I hope this helps, and hope that it got a good grade on the final exam. We'll see you then. Bye now.